Section 2.3. Our objectives for section 2.3, there's 7 of them, but a lot of them are very closely related. So first of all, calculate a line slope. Number 2, write the point slope form of an equation of a line. Number 3, write and graph the slope-intercept form of the equation of a line. Number 4, graph horizontal or vertical lines. Number 5, recognize and use the general form of a line equation. Number 6, use intercepts to graph the general form of a line equation. And number 7, model data with linear functions and make predictions. Got it? Okay, so objective number 1, calculate a line slope. If you have 2 points, can you find the slope of a line?
Yes.
Can you tell me 2 ways to do that you know how to do it?
Y2 minus Y1.
Okay, so first of all, the formula, right? Y2 minus Y1 over X2 minus X1. That's the formula for slope. The variable we typically use for slope is m. Why? I don't know either. There's not an m anywhere in the word slope.
Man, I love slope.
Okay? What? Maybe in Latin. Maybe the word in Latin is mata lolita.
There's
and that's
no
why
M in Latin.
There's no M in Latin? Oh no, we are so much in trouble. Okay, I also want you to recognize this. The change in y over the change in x. That means the same thing. We're finding the difference of the 2 y values divided by the difference of the 2 x values. How long have you been doing this?
Since 8th grade.
8th grade. Okay? You've been finding slope since 8th grade. Don't go there. Okay? So, this is one way you can find slope. What's another way you can find slope if you know 2 points? No, that's a good guess. Can't you plot the 2 points and count it?
I mean, I guess so.
Right, rise over run. So that's another way we can think of it, is rise over run. That's especially helpful when the 2 points are already graphed for us and we can just count from one point to another. Okay? Do I need to do an example for you of finding slope, or you got this okay? Example? Okay. 2, 6, and 4, 9. Okay? 2, 6, and 4, 9. Just running through the basics if we need it. X1, Y1, X2, Y2. For following this particular formula right here, we have 9 minus 6 over 4 minus 2. 9 minus 6 is 3. 4 minus 2 is 2. So my slope is 3 over 2 for that particular equation, for that particular function. Okay? Now, number 2, we're going to just go ahead and go on with this. Number 2 says write the point slope form of the equation of a line. That's our second objective. Do you remember point slope form? Point slope form is y minus y1 equals m times x minus x sub 1. That means when we're writing our equation, whoa, sorry about that, that was an awful sound. This y and this x, they stay a y and an x. We're not substituting anything in for them. Okay? The y1, y sub 1, and the y sub 2, we do substitute something in. So let's use this point x1, y1 right here. Are you okay with that? So if I'm writing this with this point in slope-intercept form, I've already found my slope. So, excuse me, I said slope-intercept, I meant point slope. Okay? So I would say y minus y1, which is 6, y sub 1, equals m, which is 3 halves, times x minus x sub 1, which is 2. Now, here's the thing that's important that I want you guys to realize. If you go on to pre-calculus or calculus, either here at this school or at other schools, I want you to realize that this is a perfectly fine answer. Okay? That is a perfectly fine answer. If it says write the equation in point slope form, that is definitely the equation in point slope form. Now, is it the most simplified version of the equation? No, but if all it asks for is an equation, that is an equation. Okay? If we simplify it, we're not in point slope form anymore, we're in slope intercept form. Because I would distribute this here and here, and I would get y minus 6, God bless you, equals 3 halves x minus 6 halves, which is 3. And then if I add 6 to both sides to solve for the y by itself, do you see what I mean? Now it's actually in slope-intercept form. Starting with point-slope form and simplifying it gets you into slope-intercept form. And in fact, it says write and graph the slope-intercept form of an equation of a line. Okay? So this is one way right here, using point slope is one way to get us from 2 points to the equation in slope-intercept form by starting with point-slope form and simplifying it down to slope-intercept. Okay? Now our next objective is graphing horizontal or vertical lines. Okay? The thing I want to remind you about horizontal and vertical lines is if I ask you to graph the line x equals 2, that is the equation, but it's also telling me where the line is. If you think about it, it's telling me which axis it's crossing and where. It's crossing the x-axis at 2. So that is a vertical line. Okay? If I say, let's graph y equals -1, it's crossing the y-axis at -1. That's a horizontal line. Now sometimes people get confused about which one is which because x is the horizontal axis, isn't it? But if it's x equals 2, it's telling me it's crossing the x-axis at 2. So it is a vertical line. Does that make sense? Any questions on graphing horizontal or vertical lines? How many variables are there in a horizontal or vertical line? Only one. It's either x or y. Okay? Recognize and use the general form of a line's equation. Okay? General form, sometimes called standard form, ax plus by equals c. If you have it in if you have it in slope-intercept form, you can easily get that equation to standard form or general form by subtracting 3/2 x from both sides. Now it has to be in this form if it's called standard form, so we've got to have the x and the y and the constant. But the other thing about standard form, it has some kind of specific rules about a and b. Okay? A and b cannot be fractions. So what am I going to do to this equation to get rid of that denominator of a 2? Yep. I'm going to multiply the whole entire equation by 2 to make that denominator go away. Okay? Now, also I know that a is not allowed to be negative. So if I'll go ahead and choose a -2 to multiply it by, do you see how that will not only take away the fraction, but would also take away the negative sign? Okay? And as long as I'm multiplying every single thing in the equation, I'm not really changing the value of the equation, am I? Okay? So this becomes 3x minus 2y equals -6. Now the next thing it asks us to do, the next objective that we have, is to use intercepts to graph the general form of the line's equation, or the standard form. Okay? Now the thing about it is, if it's in standard form, graphing it with the intercepts is the easiest way. Because you can put it in slope-intercept, and we know how to graph from slope-intercept by plotting the intercept and then using the slope to find more points. But if it's in standard form, guys, how do you find the x-intercept of an equation? To find the x-intercept, we let y equals 0. So basically, to find the x-intercept, cover up the y. 3x equals -6. What is x? -2. If x is -2, what did we let y be? 0. That's the x-intercept. To find the y-intercept, what do? Let x equals 0. Cover up the x. -2y equals -6. What's y? Y is 3, right? What did we let x be? 0. There's the x-intercept. There's the y-intercept. Now we could even check that for sure, because I know this was slope-intercept form, and look what my y-intercept was. Yep. Okay. So if it's in standard form already, finding the intercepts is easy. Even if it's not in standard form already, finding the intercepts is easy. It's like we're just ignoring that variable. Okay? The opposite of what we're trying to find. If we're trying to find the x-intercept, I know in an x-intercept y is 0. Because it's along the x-axis. There's no vertical change on an x-intercept. There's no horizontal change on a y-intercept, is there? So x is 0 in a y-intercept. Any questions about that? Okay. Number 7, objective number 7 is model data with linear functions and make predictions. If you don't remember how to do a linear regression line, that's what they're talking about here. Model data with linear functions and make predictions. You can use your linear regression function in your calculator to model the data and to make predictions based on the equation that you get from the linear regression. You mean to do that real fast? Do you have any questions about that? Do it? Okay. So I'm going to turn my calculator on. That's one of the most important first steps that you can do. Okay. I'm going to go home and make a new document. I don't want to save my old stuff. I want to start a list and spreadsheet. Okay. Now, we've been using these points all period to talk about slope and to talk about point slope and slope intercept and everything. We're just going to keep on going with those 2 points. I'm just going to remind you how to do a linear regression with these 2 points. Now, typically when you're doing a linear regression, you have way more than 2 points, but just reminding you right now. Okay. First, I'm going to arrow up here and call that column X. Arrow up here and call that column Y. That'll be very helpful in a minute. My 2 X values are 6 and 4. My 2 Y values are what did I say? 6 and 4? Pardon me. I meant 2 and 4, and I put 2 in, so I don't know what I was thinking. Okay, 2 and 4. My 2 Y values are 6 and 9, and I need to make sure that the Y value goes with the correct X value. Okay. Now I want to add a page, so I want to do Control and Doc. Control Doc adds a page. The page that I want to add is a data and statistics page. Now this is not required. Okay, we could do it all from the other page, but for us visual people, this is much nicer. Okay, remember I need to come down here to the bottom and click to add a variable. Well, that is my X variable. That's my X axis. I want to click on the left hand side to add a variable. That's my Y axis, so I click the Y. Now that I have my points on here, like I said a minute ago, I only have 2 data points for this situation, but if I had more data points, there would obviously be more points on the screen. Okay, menu, analyze, regression. Now the type of regression we want here is linear. There's 2 forms, mx plus b and a plus bx. We want mx plus b. That's the form that we're using right now. And not only does it put the equation there, put the line there, it puts the equation there for you. Once you have an equation, can you make predictions based on that equation? If you're given an X value, you can find a Y value, can't you? Okay? So, do you have any questions about the objectives that we were asked to look over today? You good? Okay.